a 0.225 kilogram sample of tin, initially at 97.5 degrees Celsius, is dropped into 0.115 kilograms of water, initially at 10 degrees Celsius. If the specific heat capacity of tin is 230 joules per kilogram Celsius, what is the final equilibrium temperature of the tin water mixture? All right. Now, let's write down our givens. We have a mass of tin equal to 0.225 kilograms. It's initially at, so the initial temperature for tin is equal to 97.5 degrees Celsius. It's dropped into the mass of water of 0.115 kilograms. The water has an initial temperature of 10 degrees Celsius. And what's the final equilibrium temperature? Okay, the only thing we really need to add is that the specific heat capacity for water is going to be 4186 joules per kilogram Celsius. And the specific heat capacity for tin is what? 230? Yeah. Alright, the specific heat capacity for tin is 230 joules per kilogram Celsius. Now, the heat lost by the tin is going to be equal to the heat gained by the water. And we write MC plus or minus delta T is equal to MC plus or minus delta T. Now, the mass of the tin is 0.225. Specific heat capacity is 230. And now we need to think about the change in temperature. The change in temperature for the tin, we'll put delta T. It's going from 97.5 down to some equilibrium temperature. So it's going to lose heat energy. So we would write that as 97.5 minus T. That's equal to the change in temperature. 97.5 minus T. That's equal to the heat gained by the water. The mass of the water is 0.115. Specific heat capacity for the water is 4186. And the change in temperature we have to think about. This is the plus or minus. Now, the water is going to gain energy. So it's going to go from 10 degrees up to some unknown quantity. So that quantity minus 10 degrees is equal to the temperature change. So temperature minus 10 is the temperature change for the water. So we put T minus 10 here. And now we just multiply this all out and solve. 0.225 times 230 gives us 51.75. And that's 97.5 minus T is equal to 0.115 times 4186. And that's 481.39. T minus 10. Now we distribute this through 51.75 times 97.5 is 5,045.625 minus 51.75 T. That's going to be equal to 481.39 T minus 4813.9. Now, T is on this side, T is on that side. It's the only variable. We have to subtract this to the other side. We're going to subtract this to the other side. So we have negative 51.75 T minus 481.39 T is equal to negative 4813.9. And then we're going to move the 5,045 over to the other side, so it becomes negative 5045.625. Okay, now every term has a negative sign in it, so I'm going to divide by negative 1. That means that this is positive, that goes away, that's positive, and that's positive. Factor out the T. This becomes 51.75 plus 481.39 is equal to, go ahead now and add these two numbers together. 4813.9 plus 5045.625. And that gives me 9859.525. So temperature is going to be equal to this divided by that. And I'm just going to go ahead and add those two numbers together. So 51.75 plus 481.39 is 533.14. And 9859.525 divided by 533.14 gives us 18.49 degrees Celsius. This means that if you take 0.225 grams of tin and put it in 0.225 kilograms of tin and put it in 0.115 kilograms of water, the 10 degree starting point for water is going to warm up, the 97.5 degree tin is going to cool off, and they're both going to reach an equilibrium temperature of 18.49 degrees.